lock this one. Okay. This is the last section of notes for the year. So you've got, I left the information for you guys yesterday where if you needed to get caught up on the nuclear assignments, you could do that. If you were all caught up and you like, especially if you were doing paper notes, if you're trying to transfer stuff over, I think I have the due date for your notes on. Hold on, I don't want to lie to you. Let me double check it in Canvas. Okay, go real quick. I don't want to mistell you guys. Yeah. Shh. Okay, so your notebooks are technically, yes, your notebooks are technically due Thursday. Okay, now there's a +1 day extension through Friday at midnight, y'all. Shush. You do have the 1 day extension through Friday at midnight, but it's going to close. Okay, so both of them. So like I said, yesterday, I let you guys work on your nuclear assignments. I have not checked the grade book since about 11:30-ish yesterday. I didn't check it this morning. I ran out of time. Let's see, I'll find the right slide. Your notes are a test grade. This assignment's obviously a daily grade. I have not put any of the nuclear assignments into Parent Portal because I was still accepting them. If you do have them on paper, you're welcome to turn them in. Don't ever turn anything into a substitute. I don't want to hear the sub lost my work because that's always the excuse. We do have one more assignment tomorrow on nuclear chemistry. It's a Google slide. It's sort of like an extra review for the Unit 12 test, which will be Friday. So grade-wise, what we have left, as far as Parent Portal is concerned, there's 3 paper assignments on nuclear chemistry. There's the Google slide, which is tomorrow. Okay, there's your openers, which are daily grades. So we've got 5 more daily grades that I have to put into the official grade book. You have your notebook, which is a test grade, they're technically due Thursday. Your Unit 12 test, which is this Friday. Your CBA, which is a regular test grade, which is next week, which even is, unless you're a senior, even should be Wednesday. If I'm remembering right. I think I'm remembering right. So you really have 3 test grades left, and you've got 5 daily grades left. I have not dropped anything extra. I'm not going to do that till I figure out how many I can. Okay, so the last thing that we're doing in nuclear chemistry, and I do have a little video that shows what would happen if we detonated all 15,000 nuclear warheads at one time. If y'all want to see it,
yes.
You want to see it? It's yeah, that's approximately how many we have on this planet. Most of them are between the United States and Russia. Nuclear weapons, bombs, MOABs, Tsar bombas, those things. The things that make the giant mushroom clouds and kill lots and lots and lots of people at once. So yeah, the big things that go boom, those. So the last section that we're doing is we're taking a look at what happens when we're exposed to radiation, like how much is necessary to cause instant death. What happens when you're exposed to certain amounts? Most of the notes that I have up here are already filled in for you. So it really should not take us that long to get through this. And I'm hoping that you should be able to finish this in class. My goal is to get done with like 20 minutes left, unless you want to watch the video, and that takes like 7-8 minutes. For the opener, there are 3 types of nuclear decay. I'm going to put them on the board. We got alpha, beta, and gamma. Alpha looks like a fishy. Beta looks like a bee with a tail on it. And then the gamma sort of looks like a cursive Y. They're all Greek letters. What are their masses? What are their masses? What are they? What is an alpha? The big one, the one that's the least dangerous. What is it? No, but what is its mass? What is it? Okay, there we go. It's a helium nucleus. Okay, and I heard the numbers. So its mass is 4 atomic mass units, which is what AMU stands for. I'm sorry, those of you that are remote, I'm writing on my board. What is a beta? E, okay, and it's a 0 and a -1. This is an electron. Okay, so this is equal to an electron, which is 1/1170th that of a proton. So it's almost nothing. Okay, this is mid strength. You can stop this one with wood and aluminum foil. And then the Y, and then what are the numbers? So what is its mass? 0. It has no mass. This is pure energy. This is the really bad one. This is what is emitted when we break down uranium into thorium, or actually any of the really nasty ones, when they break down into smaller things. It just depends. So you've got the least dangerous, which is an alpha, which is 4 atomic mass units, 2 protons, 2 neutrons. You have a beta, which is the mass of 1 electron, which is essentially the mass of light when it's traveling through a medium. And then you have gamma, which has no mass. All right, this should not take us long. There are 3 different ways that we measure this nasty stuff that we call radiation. Now, the first way that we measure it is named after the Curies. And Marie and Pierre Curie accidentally discovered radiation. They got radiation sickness. Okay, it's not a nice thing to have to deal with. But one of the units that we measure is a Curie, which is abbreviated with a capital C lowercase I. It's just its abbreviation. What a Curie is it's any radioactive substance. It could be uranium, thorium, it could be plutonium, anything that's radon, anything that's radioactive. And DPS does not stand for damage per second. It stands for disintegrations, the breakdown that occurs every second. And that's equal to 3.7 times 10 to the 10th. If I erase this, well, if I take that out of sign, to the 10th, so this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 37 million disintegrations per second. That is equal to 1 Curie. I remember how to pronounce this. Ronkin? It's not pronounced the way it looks like. A joule is a measure of energy. It's more of a physics thing. We've mentioned joules before, named after an English physicist, Joule. And it's when you give off, you deposit, when you lay down, produce, whatever word you want to put there instead of deposition. 93.3, so this is going to be to the -7th. So we've got 93.3. So we got 1, 2, 3, 4, 5, 6, 7. So this is what puts that into perspective. That's how much radiation is given to your tissue, your flesh, per gram. And then we have the REM, which is not, the other thing that stands for is random eye movement or rapid eye movement. That's not what this is. This is how we measure people that work in nuclear power plants. They have these cards. They look like a badge, and it records how much radiation they're exposed to in an REM. And they have a device that then reads said badge, because you're only allowed to have so much radiation per year, or in the case of people who work in nuclear power plants or anything else that deals with radioactive materials, they can only allow to receive so much per week. And if they hit that threshold, they're not allowed to go where the reactors and stuff are anymore. They have to wait. Because otherwise, it causes sterility, babies, and it could kill you if you're exposed to too much. I looked it up. The technicians that died at Chernobyl were exposed to like the equivalent of 160,000 chest x-rays simultaneously. That's what killed them. And of the workers that were exposed, I think it was 28 that died rather quickly from radiation sickness. Not a nice way to go. It's, you know what? I don't ever want to be exposed to it. I mean, if you are exposed to radiation and it's radiation sickness and not poisoning, poisoning kills you. If it's just sickness, that's when your hair falls out, your teeth fall out, your fingernails fall off. You've got sections of skin that fall off like you're a leper. It's not supposed to feel good. I don't ever want to experience it. There's a reason why when you get an x-ray, that tech goes out of the room to push the button.
So that you die.
No, it's not so that you die. Oh. All right, so your radiation sickness or poisoning or syndrome, it's what happens when you're exposed to too much. You know, the people that are giving you x-rays are not trying to kill you. No, they're not. You're only exposed for a short period of time. Normally, they put that heavy vest on you, except for where they're taking the X-ray that's filled with lead. And ladies, they're supposed to ask you if you could potentially be pregnant. They're not trying to pry. It's just you don't give a pregnant woman X-rays because it can cause, not necessarily kill the baby, but can cause birth defects.
That could be like 3 months premature.
Hold on, my brother-in-law.
Is she dying?
It's not my fault, Devin. Why is he yelling at me? He's like yelling at gaps at me through my phone.
You should FaceTime and call them.
No, there's funds that I may have to call him in a minute. He's like really wigging out. I've never seen him angry like before. I've seen him. I don't know. Anyways, all right. So no. There's money that showed up and like it's supposed to come to me, and because my husband passed away, they're having a hard time getting it to go. And like he's yelling at me because it's messing with his taxes, and I'm like, I can't do anything. Anyways, just wait until you have old people problems. All right, so the maximum dosage that you're allowed to get are 5 rems a year per week for the people that are working in these nuclear power plants. It's 100 millirems. That's what the M stands for per week. If you hit that threshold, if you become a person that works at a power plant, you hit that threshold, you're not allowed to go play with the radioactive stuff anymore. You have to wait. Now, we get this stuff all the time from the sun. It's background radiation. It does depend on how far up you are in elevation. At sea level, we actually receive less radiation from the sun because our atmosphere does a really good job at trying to filter it or absorb it. The higher we go up in elevation closer to the sun, the more you're actually exposed to. It's easier to get a sunburn when you're higher up in elevation than when you're at sea level. Just for your information, if you ever go skiing, you need to wear sunscreen. Doesn't matter if it's cold, you will get sunburned. You guys have this on your paper. You have both charts. I didn't put the other chart on the paper because I couldn't fit it on the screen. So we've got actual radioactive substances, how much you're going to be receiving per year. And once again, the M is milli. Cosmic rays means from the sun. Okay, we're at like 750 feet above sea level here in Azle. I've actually looked it up. So we're really not that far off of sea level. If you're in the mountains in the United States, the Rockies, then you're going to double that. If you go to like the Himalayas, then the higher up you go, exponentially, the more exposed you are to radiation from the sun. It has to do with how thick or how thin the air is. And these are just different things that you can be exposed to. X-rays, whether they be for your teeth or you break a bone, obviously that's a heck of a lot more. They're not going to expose you to X-rays for a long period of time. Acute means quickly. Okay, chronic means repetitious. When we drop bombs on Japan, both Hiroshima and Nagasaki, the people now some of them died, obviously, it was a nuclear bomb, but the people who didn't were exposed for a brief period of time for the radiation. That's acute. Chronic, and this is sort of, people who mine uranium ore, it's a dangerous job. They tend to get radiation poisoning. You know how watches glow? Well, I know people don't have watches anymore. You know how they glow in the dark after they've been exposed to light? You go back in time, and there were people that would literally dip their brushes into this radioactive material, and then they would use their mouth to twist it into a fine point. So they're literally ingesting, not knowingly, radioactive material, and then they would paint the dials so that they would glow. Obviously, we don't do that anymore. So, but this did happen. All right, what bad things that happen? Gosh, damn it, Devin. Yeah. He is totally I have no idea what's going on. All I can do is call my financial person. All right, so not that you're going to necessarily get leukemia if you're exposed to radiation, but it is the most common blood disorder. Okay, you need to understand that your bones are what makes your white blood cells. You should have learned that in biology. But leukemia is not something that you want. I don't know if you know anybody who's had it. Chemotherapy is going to be the primary way to try to fix that. It does not always work. Leukemia tends to be more of a young age issue, but it doesn't have to be from young children. It can cause, okay, so retardation does not necessarily mean like missing a chromosome. It just means stunted. Okay, so you're going to have issues with children growing properly. It might be a height issue.
I just wonder.
No, it does not mean stupid. The word retardation means to like be like not normal, like hindered is what it means. It does not mean stupid. No. Anyways, you're gonna have chromosome problems, which will cause birth defects. I didn't look up every single different type. I'm not gonna go that far into it. And yes, it can cause mental retardation, which is what you think of as stupid. Okay, so the lower IQ issues. Swear. In utero means that specifically when the mother's pregnant, so unborn children. And like I said, ladies, when you go to the dentist, when it's time every year, every other visit, you're supposed to have x-rays done of your teeth. They are supposed to ask you if you could potentially be pregnant because of this. But they still put that nice, heavy, like, vest thing on you, which is filled with lead. That's why it's so heavy, and it actually protects the important organs, the heart, the liver, the lungs, the kidneys, this part of your body from the radiation, yeah, from the x-rays.
When people like
Well, how you're gonna read what you're doing. I don't remember if I have another thing on here because I forgot to print the stuff out. Wait, did I put this one? Negative, I did not. Oh, that's it, that's on this one. Now, the one that I did skip over. Okay, you have this big chart. And for those of you that are online, it's on your notes. To be able to answer the questions on this paper, it has this sort of like, has this person that's going through his daily routine as far as you trying to identify where the radiation could be entering this person, however they're exposed to it. A lot of the questions on the back, it says notes 55, it's actually notes 54, that's a typo, I need to fix that. But you're going to be using your notes to be able to answer the back of this. And then you should be able to get almost all of it, if not all of it, from here. The only thing I did not go over was this chart. I'm going to turn the light off. I'm going to get paid. I don't know how to do this. So, as far as this chart is concerned, up to 25 rems, you're going to have red blood cells specifically reduced, which means anemia. Okay. Anything above 25 is going to start affecting your white blood cells, which is your immune system. Should have learned that in biology. At 75, you're going to have blood disorders, major issues. 150, you're going to start feeling sick, throwing up, diarrhea, flu-like symptoms, start losing hair, start losing weight. 200, it says you'll survive, but you're going to be real sick for a long time. 250 is when you start having death. 450, everybody's sick. 50% of people exposed to that amount will die within 30 days. That's lovely. 300 to 600 is going to have infertility in women. It takes more for men. I'm not sure why. It takes up to 200 more for infertility, like permanent infertility, not like you can go to the doctor and you can fix it. And anything over 2,000, everything's going to die, like instantly. And like I said, the ones that were exposed in Chernobyl, it was like something like 160,000 simultaneous x-rays. Now what I do have, you guys want to watch the video about launching all the nukes? All right, let me stop the presentation and change it to this tab. Let me make sure I have the right one here. I'm going to make that bigger. Hold on, give me just a second. I have to mute my mic or it makes it sound really weird.
Many of our viewers have asked us a very serious question. What if we made a big pile of bombs and exploded every nuclear weapon in the world all at once? Strangely enough, we couldn't find a good source to answer this question to our satisfaction. So, we gathered together a few scientists to calculate what would happen and find an answer to this extremely important scientific problem once and for all. Currently, there are 15,000 nuclear weapons on Earth. The US and Russia both have around 7,000, while France, China, the UK, Pakistan, India, Israel and North Korea own around 1,000 between them. But how much destructive power is this really? Let's try to put these numbers into perspective. On Earth, there are about 4,500 cities or urban areas with at least 100,000 inhabitants. Some are bigger than others, so we'll assume that on average we need 3 nuclear bombs to completely wipe out one city. This means we could destroy every single city on planet Earth with our nuclear arsenal, killing more than 3 billion people, roughly half of humanity, in an instant. And we'd still have 1,500 nuclear weapons left. Now that's what an expert would call overkill. So we can say with confidence that we have a lot of nuclear weapons and they can do a lot of damage. But what if we make a huge pile of all 15,000 bombs and pull the trigger? Let's drop our nuclear pile in the middle of the Amazon rainforest, just to show nature who's boss. Our warheads, piled haphazardly, fit into a small warehouse. A typical US warhead has the power of 200,000 tons of TNT. So 15,000 warheads would be the equivalent of 3 billion tons of TNT. For scale, this is enough to rebuild the whole island of Manhattan with every building and skyscraper using stacks of TNT. The closest thing we can compare to the energy gathered here is a volcano. One of the deadliest volcanic eruptions in recorded history took place in 1883 on the island of Krakatoa. The eruption was so powerful that 70% of the island and the surrounding archipelago was destroyed, killing tens of thousands of people. Its effects were felt around the world for days after the event. Our nuclear pile contains 15 times the energy of the Krakatoa volcanic eruption. So let's finally push the button. 3, 2, 1. In a second, a fireball 50 kilometers across vaporizes everything in its way and creates a blast wave that flattens 3,000 square kilometers of forest. Every living thing within 250 kilometers will start to burn. The explosion will be heard literally around the world as the pressure wave circles the Earth tens of times over the next few weeks. Millions of tons of incinerated material are catapulted into the atmosphere. The mushroom cloud reaches the outer reaches of the stratosphere, pushing up against space itself. After things have calmed down, a small crater, about 10 kilometers across, is left in the center of the worst wildfires the planet has seen in millennia, spreading throughout South America, burning down forests and cities alike. And now, the unpleasant part begins. Extremely radioactive material will kill living things very quickly, and a large area several kilometers around the crater is now uninhabitable, as is everywhere for hundreds of kilometers downwind. Much of the fallout is carried high into the atmosphere by the mushroom cloud and carried around the planet. The amount of radioactive material in the environment doubles worldwide, which still isn't civilization-ending, but we may see more cancer for a while. A portion of the particles will float to the edge of space for years and cause a nuclear winter that could lower global temperatures by a few degrees for a few years. This explosion was pretty bad if you're in South America and especially Brazil. The Amazon rainforest is pretty much history, which is not great, but human life will go on. Okay, but what if we explode more nuclear weapons? Let's suppose humanity decided to mine every bit of uranium on Earth and build as many nuclear bombs as possible. At current usage, it's estimated that there are around 35 million tons of uranium in Earth's crust, enough to power human civilization for over 2,000 years, or to build millions of nuclear warheads. For the sake of argument, let's say we create a pile with the yield of 10 billion Hiroshima bombs, which makes up a cube 3 kilometers high that contains roughly the energy of the asteroid impact that ended the age of the dinosaurs 65 million years ago. Except it's also nuclear. 3, 2, 1. Our pile explodes in a fireball stretching so high into the sky that it's visible from half of South America, with so much power that the ground just splashes like water, forming a crater 100 kilometers across. Bedrock on the scale of whole mountain ranges is vaporized in an instant, while thousands of tons of material is catapulted away with such speed that it's ejected into space. Some leaves Earth forever, while most of it comes raining down as hot, burning debris that heats up the atmosphere to oven-like temperatures, killing most big animals and causing firestorms all over the world. The Earth's crust rings like a bell, struck by global earthquakes stronger than anything in recorded history, decimating cities around the world, while hurricane-force winds flatten every single tree in South America and wildfires consume the continent. The abundance of hydrocarbons in the Amazon burned to form ash are cast into the atmosphere, darkening the sky and keeping sunlight from reaching the surface, dropping temperatures to near freezing worldwide. The ensuing global winter may last for decades and results in the extinction of every large animal species, humans included. We could also mention that every corner of the planet is covered with radioactive fallout, but at this point, it doesn't matter that much anymore. This is humanity's extinction event. The astronauts aboard the International Space Station get to enjoy a great view for a while, but it's not unlikely that the spray of rocks blast into orbit will destroy the station. Those lucky enough to be in bunkers or in submarines deep below the ocean surface may survive the longest before they exhaust their food supplies and have to venture out for more. They'll find the world a charred, freezing, radioactive wasteland. The planet itself doesn't care at all. After just a few million years, the wounds of the explosions have healed and life is thriving, arguably even more so than when humans were around. If intelligent life emerges again, it might be able to work out what happened. When they study geology, they'll find a bizarre and very thin layer of rock covering the entire world, enriched in radioactive elements like uranium and the other nasty things it decays to, mixed with rare earth metals and plastics that humans used. They would probably be very, very confused. Videos like this one take well over 1,200 hours to finish. Over the years, we put more and more effort into research, conversations with experts, illustration and animation, sound design and fact-checking. For this video, we put a lot of extra work into our sources document. You can read how we got to the information in the video, what our experts thought about it.
Okay, so there's actually a bunch of other videos that I can show you, but we have, what, 20 minutes? So if you did not, now I think the nuclear ones, the other ones that we did, I'm pretty sure that link went down at midnight, but I know some of you may have paper versions that you need to turn in. Where is my, okay, this is what I need to freeze for more space. But I never want you, why is that not doing that right? I want you to be big. There it goes. If you have the paper versions to turn in on the last couple nuclear ones, for those of you that are in person, awesome. I just haven't put them into Parent Portal. I was yanking stuff off of the grade book. This is the only one I've not graded yet. And this goes here. Tiffany on. You turned all the other ones in. So, not in this section. As long as you turn this one in. Oh, and I have it. It's right there. Mm-hmm.
What papers on the lack table?
Just the nuclear stuff. The one, there was this one, which is the only one I haven't graded. That was from Friday. Obviously, there's the one that's today. There was one that was like types of radiation. And then there was that nuclear gallery walk thing where you're filling out like 9 different things. Let me check. There's so many different things going on at once. Let me check. Canvas. Like I said, I haven't checked this since about 11:30 or so yesterday. Oh gosh, everything is so slow. And there's not much left. Like I said, there's a Google slide tomorrow. We'll review your test on Thursday.
What's
Test
her sheet?
itself will be what?
I will probably not be okay.
Figuring it out then.
Do a test run. I can still get on Google Meet though.
That's fine. Holy, this kid. Oh.
You got a game.
I've had it for forever. When I do documentaries with my Earth space, I always bring my personal computer so I can do the stuff I have to do because this is being used to present. Okay, so I got Declan's here. And then I've got one from Caitlin here. Make sure none of those were turned in. Types of radiation, no. Okay. Let me do this. $16, so 15 to 85.
I keep getting like these emails from
College.
Did you fill out any kind of like?
I didn't even, I got like 17 of them.
from like the essay.
I was gonna say you had to have filled something out somewhere.
You didn't get for college too?
I mean, it's that time of year, so. Oh no, y'all are juniors, most of you, right? Or you're sophomores. Oh, that is a little early. We normally really get after you guys when you're junior year. You've been getting them.
I've gotten like everything after this.
Yeah, you fill out some type of like not like a poll, but like I can't remember what it's called. Yeah, there you go. That'll work. Because I remember doing that too when I was your age. You know, that's what I did. Because I'm from this area. I went to it was TCJC back then. They dropped the junior part of it. But I went there for, was it just 1 year? And I got to do basics. It's so much cheaper to do it that way. And then when I moved down to, I lived in Bryan for a year, and I went to A&M's junior college, which is called Blinn, for a year to make sure I wanted to be in that area. And then I went to A&M. But yeah, it's so much cheaper if you do a junior college or a community college or whatever you want to call it, as long as you're sure that they're going to transfer. It's just so much cheaper. And school's a lot more expensive than when I went to. So you need to make wise decisions on what you choose to major in, because a lot of A lot of diplomas are not worth the paper that they're printed on nowadays. Unless you go and, you do in college. High school's different.
No, high school, they just knew, they handed out you the folder graduation.
I think it's been like that for forever though. I don't
I
remember.
didn't buy that off mission.
But yeah, in college, you'll get an actual, well, okay, when you walk, they don't give you the actual diploma. They mail that to you. They don't hand it to you. Well, at least that's how it was when I was in school. Okay. Here's your plan. But I should be able to put all this stuff into.
It's just actually good in my opinion.
You submitted your thingy? Check it. Let me. So I got one here for Kyle.
That was like a concern.
Great. I'm just looking at a digital one that I'm grading real quick. No. Oh, Lordy. It's going to rain all week long. Okay. And then when you're ready, you can start doing your notebooks. The earlier you get it done, please don't forget to take stuff off of restricted, please. I'm gonna have slides, and we're gonna have unit 12 test.
I saw a video of someone walking in the evening. I saw you walking in the evening. I'm gonna give you a ride. So I can give you a ride because my phone has been being slow all day. Because it's so great. I'm hoping the power goes.
You're hoping the power goes up?
How do you feel?
Let's see here. So this goes here. This goes here. This goes here. Okay, and then Tiffany. So